Hello, everyone. This is the second part of streaming with Python. And in this session, we will be covering the PySpark structure streaming and how we can communicate with Kafka cluster and Spark cluster. In the previous session, we started our Kafka Dockers, but I needed to stop in between the videos, but let's start that. And if anyone would like to, if you already have up and running Kafka services, you don't need to follow this one. But let me go to the Kafka and just do Docker compose. And this is creating, as in the previous session, this will be creating the Kafka services. And let's also check, and also I would like to mention, like in the README, we needed to follow some steps, especially for Spark, build some images before the Docker compose, create network, and create volume. For me, I already have this volume and networks and images, but let me show you how it should look like after following first and second step. Network. Yes. This will show me it should include the Kafka Spark network. This will be the bridge network that allows us to communicate between Kafka and Spark services. And then Docker volume, yes. And this should include Hadoop distributed file system, and this will be used as a replication of HDFS to store some logs, some messages in the specifically for the Spark cluster. And also, let me show you the images that I have. This should include Jupyter Lab, Spark Worker, Spark Master, Spark Base, Cluster Base, all of the images that you should have. And these images are created based on the Docker files that is defined under Spark folder. And these are created based on some considering some layering, and each of the Spark Base, Spark Master needs some specific configurations. But I will not explain how this layering is going to work. But I highly suggest to read through Andrea Perez's Medium blog post that explains how this layering works and why we are building such a layering system that is going to be used in our Docker compose. Right? And let me. Right now, what we can do is we are having, let me check, yes, and my Kafka cluster and my Kafka services is up and running. And now I will be using same for Spark. And I will be running Docker Compose again. And it will create Jupyter Lab, Spark Master, and two Spark Worker nodes. Let's one last time check the Docker PS just to ensure everything is up and running. Yeah, exactly. My Kafka cluster running for 3 minutes, and also Spark is just started. Good. This is all we need for starting the services in our local machine. Let's move to the streams example with PySpark. Within this example, I will be using two different, another set of consumer and producer. These are quite straightforward and follows the same pattern as in the previous example, like RO and JSON example, but they just differ as just how we decode and encode our values and keys. And just to keep it simple, because this is not the main focus of this tutorial, we will be just keeping simple, and we are encoding string to a binary and also decoding that from binary to string. Just as an example, we are not doing any specific type of deserialization and serialization steps as we did in our example and JSON example. This is a simplified version of it. And you can see that in the producer, we just encode, and consumer, we just decode and move to integer and decode. Yeah. And let's run our first producer, and this producer should create messages in our topic, route CSV topic. And let me run this. Producer.file. Okay. We just created 5 reports, and let's simulate the exact same thing for consumer. See? And it accepted, and it didn't end. And if I run it again, the consumer keep getting the messages. All right. Let me stop that. This was the base that we needed. We already have some messages in our CSV topic that we produce topic to rise, and now we needed to consume these topics by using the PySpark structured streaming system. And as we already have PySpark, we needed to set up, we needed to use Spark context. But before moving into the Spark streaming.py script, I would like to go and show some of the concepts in the streaming notebook. You can access it because in our, let me go back again. For example, let me do the PS again. And for example, we already have Jupyter Lab defined, and this Jupyter Lab is running in 8888 code. And now what I will do is I will show some of the concepts and their immediate outputs in Jupyter Notebook, and then we will be coming to the streaming script, and we will run it in a more production way or more continuous way, and we will see some outputs in our console. Right. Okay, this I just opened it before I run my Docker, and now after I run my Docker, this port is already available and it's already knowing the streaming. Let's start. First is Spark setup. To be able to connect Spark with PySpark with Kafka, we needed to install and say some specific in jar files like Spark SQL Kafka, for example, and also Spark Arrow jar if we are running with our deserialization and our specific configuration. And we needed to have PySpark shell for being able to run in a Jupyter Notebook. Okay, let's start. Okay, and I'm creating the first Spark section. When this Spark session is being created, is try to follow this PySpark submit arguments. Try to download this jar files in place, as you see. And now it's finished. And even though it's red, it's just a successful run. And now we can move to our streaming example, basically. And we can read by using PySpark structured streaming. We can read Kafka streams directly, and this can be done by read stream. And we needed to specify a format and options format has to be Kafka, and options we need to specify bootstrap servers. I already mentioned in the previous session, like these are the localhost 1992 is the host that we are using for external access, but we still needed to provide this internal broker to the Kafka broker servers. And here we are also specifying which topic we would like to subscribe. It is right CSV, the topic that we have created messages a couple of minutes ago. And we are setting up starting offsets and earliest. We set up as earliest, but we can also say latest, for example, and it's just keeps getting only the latest messages. And checkpoint location is what Spark needs. It stores basically, for example, when I specify checkpoint location as checkpoint, it creates the folder, and it's basically keep offsets for specific messages and keep track of which messages is being read and which ones are still waiting. Let's run this one. And later we can also check what is the Kafka looks like. All right. What I want to say is in this, whenever we read something from Kafka topic in the PySpark, it has key value pairs that contains our data that we have sent to the Kafka topic, but also a bunch of other information, topic, partition, offset, timestamp, and timestamp. This information might be useful if you are running, especially on some kind of metric analysis or some kind of productionized system. But in our tutorial, I will be focusing on key and value, just to show how we are getting data back from Kafka and to the Spark, the Kafka message to the Spark. And one important thing I would like to say is, as you see, key and value, they are in a binary format. That's why we needed to do some transformation to be able to make it human readable, convert them to string, and then apply some manipulations to be able to convert it to a specific schema later on in basically next step. Okay. This is basically telling us we can do some select statement and casting on the Kafka, but this will be included in the structured streaming data frame. As you see, as I said, we needed to do some parsing in our raw Kafka messages, Kafka data frame. And what we are doing is we are first checking if this DF row that we get as an input is streaming data frame, because in Kafka, in PySpark streaming data frame, everything is classical data frame, but they differ based on this is streaming parameter, and that's also change how we reach the data inside this data frame. That's why I just wanted to add this true or false sort comment. We are first selecting between only the key and value columns from the row, and we are casting back because these were in binary. We are casting them as a string that we can extract some valuable information. And the value column contains basically all of the data that we have sent in comma separated format. In here, by using the PySpark function split, we are splitting columns in this by using the same comma separated pattern that we have write the data. And here we are basically expanding the column to multiple top level columns. And at the end, we are doing a select statement that basically selects only the column names that is defined in the schema. It can be more obvious when, for example, when we run the code. For example, our write schema include vendor ID, pickup date time, drop-off date time, passenger count, trip distance, payment type, total amount, and this information. And what is after this parse write from Kafka messages, which is basically the Kafka row, which includes key value pairs only, become a data frame that contains all of this information as a call. Let's run it. I forgot to run it. Okay. Let's run this one too. Okay, and let's print screen. As expected, like we now have all of these columns as it is. But let's now try to, because it looks like a normal data frame, right, in the PySpark. But whenever we try to do the write show, it will complain about, okay, you can't just show your data frame because this is a streaming sources. We needed to use write stream. Write stream is a way that we can decide how our streaming data should be outputted, should be synced to a different environment. Right? And yeah, and this brings us to the sync operations and streaming query. There are multiple different ways. The sync operations is happening with write stream function. But there are different ways of different types of output syncs. For example, you can write your streaming data into a file. You can send back another Kafka topic. You can apply some aggregation or some kind of queries or based on the batch or using the for each sync, or you can just sync in a console or sync in a memory. Sync in a console and sync in a memory is more like for debugging purposes. It is not for production, but it's also good for us to see what kind of information we are getting back. That's why I will be using console sync quite a lot in this tutorial. And there are a couple of different output modes. One is complete, append, and update. These are really differs based on set transformations that we applied. For example, if we are doing query in group by operations in a non-time-based time-based column, we can't really do complete. These are some restrictions that Kafka Spark streaming has, and these can be found in the output modes, for example. For example, you can read through and you can decide which operations you can do on one different set of queries. Likewise, Spark, even though Spark structured streaming is a streaming engine, it's not a fully functioning streaming engine. It still includes some kind of delay, and it's rather than it's process the data or messages in real time, it's processed in micro batch mode. And therefore, you needed to define how your micro batch should look like. You can define a fixed interval. You can say, okay, I just want to read one time, and you can say whenever new data is available, I would like to trigger. These kind of things you can set up by trigger settings. In this tutorial, we'll be using mostly with fixed interval micro batch, and we will be triggering most of the queries every 5 seconds. Just if data is available, it will be giving us some sync outputs. All right. The first example can be sync console, and this sync console, as I said, it's using write stream and output mode as complete and trigger every 5 seconds. And format will be on console, and therefore it will be producing something on the console, and the additional parameters like truncate, bold, or you can also specify additional options as well. But at the end, whatever it returns is streaming query. It's not a direct data frame. It's streaming query that you are keep running, and you need to stop if you don't want to use it anymore. Otherwise, it will keep looking for this information based on the new data, based on your processing time and based on your trigger configuration. And now, for example, sync query, I just run it for df writes in append mode. And it will show me the first set of produced messages as an output. But for example, if I go back and, for example, run producer one more time for another 5 messages, it will create another batch with the new data because we just say it's in append mode. It will not show the whole data sets again. It will just show the new ones. Now, as you see, I didn't do anything. I didn't rerun this sync console, but it automatically takes the batch. That's why to stop this query, I needed to stop it. Now, even though if I push new messages, it won't take it. Likewise, we have sync memory that allows us to keep our some streaming data in data frame format. For example, in here we needed to specify query name and format as a memory, and query name and for example, this one starts as we can run query string on this one, and then on this write query query, and then this will create a write query as it is in the console, and also some intermediate results that keep it in memory. These are basically the data frame format. And for example, if I check the example, query name is vendor ID counts. This is how we this is defined in this part, and this is how we do our queries on there. For example, I define a query template which expects a table name, and this table name has to be this query name. Otherwise, they don't know each other and they don't know where to query the expected select statement. Let me on this one. All right. And now, for example, whenever I see white query, let's see what is it type, and also let's see the status. Right. Now I can able to DF vendor ID counts because this is kept in memory. It is not anymore a streaming query. Yeah, we get the results. And now again, I needed to update the and stop the query manually. And the last part is for sync operation. We can do sync Kafka. We expect data frame, topic, and output mode. Complete output mode is not supported for Kafka sync operations, as well as specified as an append. But here, as we did in the read stream, we need to define format and option Kafka book service options, output mode and option as a topic, and checkpoint location as well, because this is the same setup as the read stream. But what is important here is sync Kafka operation to be able to start this df write stream format Kafka. Df data frame that we are working with has to include some kind of specific columns. It's always expect to have value column, and it also suggests to have a key column as well. That's why before running sync Kafka, we needed to define, okay, what is the key and value for my Kafka topic, and I needed to merge them using the concat res, again with the CSV format, and then ensure my final data frame includes key and value columns as well. I will not run it here, but I will show it in the script part. Of course, addition to that, we can also run a bunch of queries and aggregations, but I just want to keep it simple here, and we will see further details in the script part. Right? Now, let's go to the streaming.py and let's go to the main method. What this function does, it creates the Spark session and sets some Spark context and local level warnings. Nothing specific. We already did the same on the notebook as well. We don't, in here, we are using some read from kafka and posting topics like CSV. And this read from kafka is exactly the same code that we have seen, like read stream and write it. And likewise, and afterwards, I will be just printing out the schema and then parse writes. And again, we already covered that part, and it will be basically expanding column to value column to the multiple level columns and in our expected schema format. And we will be also printing the schema as well. Be careful, these values are all in query, streaming query object type, and we can directly access them. But what we can do is we can do sync console by write stream, and we can specify, we can read what kind of messages we get on our console. Okay. And after the first part, we are doing some kind of aggregations on the existing VF bytes. And one of them is group by operation, and the other one is group by windowed group by. Let's take a look how they look like. Basically, group by operation just takes name list of column names and group by the operation and return a DF aggregation. This DF aggregation is still a query type. It's not a direct data frame. To be able to read it, we needed a write stream operation. And likewise, window group by also same, except nothing changed in the logic or nothing changed with the data types. But in here, Spark allows us to specify specific windows based on time-based columns. For example, in our data, the pickup date time is date time, and we can use this as a window parameter. And if you wonder how this window parameters and works, I think there are a bunch of examples in this document that we can check. But also, I think Ankush already explained well in the previous concepts Kafka concept session. Sorry. And then we are expecting to sync again. I'm sending also the trip count vendor ID. It will produce some vendor ID and count information to the console. And as a last part, I'm getting this using this DF trip count by pickup date vendor ID and prepare for data frame the Kafka string as we did in the previous session by saying, okay, our value column will be count and our key column will be vendor ID, and send this as a message in the new Kafka topic. And all of them will be running as long as we stop this application. And we can do, and maybe later we can also need to do additional aggregation on this specific topic, and we can do some write to a file sync operations later on. I don't know. It really depends on what your program needs. And this Spark script await any termination ensure that your application keep waiting new information, new messages as long as something happens and you stop it intentionally. Okay. Let's run it. Okay. One important thing that I want to mention is whenever I'm running the streaming.time, I'm not using like Python 3. Let's first do that and I can show you the error. And streaming.py. It will try to do some access it, but the way Python 3 stream.py is not suggested and is not matching with what is the suggested structured streaming plus Kafka integration guide. That's why I created a Spark submit script. Basically, this script is defines gets our Python job and send this Python job as a Spark submit application by some specific parameters. And the specific parameters are really important because it allows us to communicate with Kafka. It allows us to specify, get schema registry access, and it's also important for stream Kafka communication. That's why we are not running as Python 3 and stuff, but we needed to run it as where was it? Spark submit. Let's see the outcome, and afterwards we can also retrigger another producer, and we can see the outputs are retriggered as well. Sync operations are retriggered, and as you see here, the Spark installing some of the jar files that we have specified before getting started to run the application. And for example, here, this is the first sync operation that's just prints out the raw data frame that we get from the Kafka. And then this is after we specified our parse method. Okay, it's failed. This thing. I think I know because I restarted everything. Let me delete this checkpoint and okay. Because I already ran a couple of times this example. It was trying to find a different probably the offsets and stuff. Let's see. Okay, it first to sync the complete batch, and now we are expecting to sync operation on the vendor file vendor ID. Because it just did this one. Okay. It also produced this one. Let's reintroduce the producer, and we will now get new set of information and also this new batch of these two sync operations. okay, only because we use the append mode. We just get the new records rather than we are getting complete stuff. And now our render ID count values should be updated because we created new set. Yeah, exactly. The count is updated. I think we can end the session. Hope this session helps you to understand how Kafka and PySpark streaming works together, and hope you can use it in your final project in the data engineering. So see you later. Bye bye.